Hello.
Nice to meet you again. How are you
Nice to
doing?
see you. Good, thank you. How are you?
Yeah, very nice. We look forward to your presentation. So this is a slightly different presentation. So pretty much all the presentations have been focused on the classic sort of um, display markets, but this is about flexographically, so roll-to-roll printed OLED indicators and passive matrix displays. So somewhat different. And yeah, we look forward to your presentation.
Thank you.
Yeah, so start whenever you wish.
Okay, great. Well, thank you so much for having me today. And as you mentioned, I will be talking about Sinovia's work in flexigraphically printed dynamic OLEDs. So, as you're all probably aware, there has not been very much innovation in low cost displays in the last 50 years. And you still see products that look a whole lot like these, still using display technology that looks a whole lot like this. And this makes a lot of sense because most of the R&D is focused on brand new technologies, and when there's R&D spend on new technologies, they tend to be on the higher end and the more expensive end of the display spectrum. And products like this just do not have the bill of materials room for a high-end display. And so this leaves all of the product designers and the manufacturers of these products looking for new display technologies, but not being able to afford them. And products are only getting smarter. Right now, according to IoT analytics research, there are over 12 billion connected devices today that are not computers, TVs, or smartphones. And that number will grow to over 27 billion by 2025. And these IoT products are defined by the data that they collect, so from sensors or inputs from the world around them or the users, functions that they perform. So, for example, a smart thermostat would learn about your day and heat your home, or a smart lock would open up your door. And then information that they communicate back to the user, whether that's a temperature status, whether that means your door is locked or unlocked, or something else. They do also have some very specific design constraints. So generally, they have small form factors. Many of them run on batteries. And as I mentioned in the previous slide, bill of materials costs, they're very sensitive to these items. So displays and indicators for these systems need to be thin, they need to be low power, and they need to fit into the bill of materials of the overall product. So you can't put a $100 display in a $20 IoT device. So Sinovia's work is that we're using flexographic printing to print OLEDs for smart products and interactive surfaces. And our early customers are using them to grab user attention, to communicate the status of a process that an IoT device is performing, or enhancing the product safety. So, communicating with the user that something has gone right or something has gone wrong, or that they need to be alerted to a status that's happening within the product. So, really, the question is, how can we do this? We have developed a core technology that serves as a roll-to-roll transparent conductive film that allows us to print the OLEDs roll-to-roll from start to finish. So you can see a picture of our transparent conductive film there. It is printed additively, roll-to-roll, at less than 100 micron resolution, and it has a nanoscale smooth surface, which allows us to build and print that OLED directly on top of this layer. So the way that a bottom-emitting or patterned OLED works in this case is you have a barrier substrate for encapsulation, then you have your anode on top, and this anode really defines the shape and size of that OLED. Then you have your organic layers printed on top, and then you have a cathode. In the case of this example right here, you're looking at a passive matrix. So the anode stripes would move in one direction, the cathode in another. And where your anode and your cathode overlap, you get light emission. Now, this doesn't have to be a passive matrix. Because we're using printing, we can really print any shape that is required by the application. So as you saw in the previous slide, we can do segmented displays, we can do